There is really annoying flickering on the screen. It's also on YouTube.
Yeah, the top part of the background is usually
Ah,
indistinguishable.
scheiße.
It's flashlight. Oh,
Okay, sorry for the flickering. I can try the other computer. And the problem is my usual laptop is broken. But it broke 2 days ago, but I was really busy. Hello.
hello.
But is there a big shop with components for computer in Moscow? So where you can just I need new CMOS battery in my laptop. It's very stupid. But I only found it on Yandex Market, and then they say, oh yeah, courier has it, but he doesn't deliver. It's so I take another laptop.
For the laptop.
Well, there exists a battery. There is like permanent memory for booting. It's called
Oh.
CMOS battery.
Oh dear.
I just need a new battery, stupid 3-volt battery, and I can use my laptop again. But this battery I could only found on Yandex Market, and then it goes to a courier, and then this courier doesn't deliver. I said, please take 10,000 rubles, just give me stupid battery.
But your laptop works when it is charged.
No,
I mean,
there is a little battery that keeps CMOS memory for booting. If the battery is gone, the memory crashes and my computer cannot boot.
Oh.
And I just need to charge it with 3 volts and I can use my laptop. At least it's my current hypothesis. It's all about this battery. But if I detach and then move a little bit or heat it up and then I attach again, I can boot. And then he complains that he has to reset his memory, but he does it. But it's almost certain that's the problem. But yeah. But just why is there? Nowadays everything is online with courier, but then if Yandex Market website is doing stupid and I cannot get so now everything is a mess because I try other laptop. Usually I have exact second laptop that has, if one crashes, I can immediately switch to other one. But I was too lazy while traveling. I left it somewhere. I said, oh, what was the chance of it? Okay, doesn't matter. That's yeah, I'm just a bit because all the small things I have to do take forever. Because so if somebody, maybe it's just better if somebody records the lecture on the phone or something, or I never, maybe I can try my phone and record. So I have a laptop for recording, but the screen is flickering for some reason. Are there people online? Okay, so nobody online, but Okay. So let's start. So today it's really cool lecture. At least I think so, because well, it's cool result, but a bit technical lecture, and so and you already know half of the lecture. So what's the goal? So we learned about a priori probability. There is a measure that is bigger than every other computable measure. And now the plan is to use it to optimize some loss. And so we have two tasks, non-responsive systems. That means that we take actions, but these actions do not influence probabilities of future observations that we get. So we want to optimize a loss function that's depending on future observation and our action. So let me give a small example. So I go outside, I predict whether this afternoon it will be rain or sunny. If it's sunny, I will go in t-shirt. If it rains, I take umbrella. And so depending on the outcome, I receive some loss. So when I go in t-shirt and it rains, I receive maximal loss. But if I go with umbrella and there is sunshine, then I receive a small loss because it's annoying to carry umbrella. And so we want to optimize predictions. And so we assume the system is non-responsive. So that means my decision to take umbrella will not change the weather in the future. So, but this is different. Or the other example is stock market. I pick a stock, and if I play with small money on big companies, then my decision doesn't influence any prices of the future. But if I'm central bank that decides to buy billions of gold, like China or whatever, then sorry, you were the last week, and I somehow confused the phases. Yeah, okay. So I confuse phases and name all the time, so don't worry about it. It just I need to remember a lot of things, and okay, you know the problem. But we will also speak about responsive systems. And so we will prove a result for non-responsive systems, which is like very tight and quantitative and hopefully convincing. For responsive systems, we only have qualitative results. We will say that, okay, if we predict according to universal probability or some variant of it, then in the limit, we will make good predictions. But there is no bound that says how much we will lose before the predictions become, the strategy becomes good. Okay, so this is our plan. So two goals. And we start with non-responsive systems. So now, well, our previous proof, so we discussed Solomonov priori probability for predicting conditional measure, and we had fast convergence. And we spoke about binary alphabet, but proof works for general alphabet, general finite alphabet. So the result for general alphabet is stronger. You cannot get it from binary alphabet, but the proof is the same. So in the notes, it's hopefully carefully written, this part. So there are still many mistakes. So I will continue reading, and somebody sent me some more. And hopefully in a few days. So I lost my laptop 2 days ago. It's just hopefully temporarily broken. And now all my tasks go very slowly, like just logging in overly refuses me to say that thinks I'm an attacker or something. So just in a few days, I have my laptop back, and then I produce the materials as fast as I can, so that hopefully in 10 days, you got at least for 4 lectures the material. I mean, probably in 5 days, you should have everything for 4 lectures. And so in the seminar, I will just write the questions on the board. Okay. Yes, now let's start. So we have, so what we're going to do is, so we, there is a finite alphabet of actions. So for example, take umbrella or go outside in t-shirt. So actions is finite set, but also observations is finite set. And that's a good idea in computer science. So observations, I will use X. Okay, so finite set of actions. Here also finite. Do I have anyone on Zoom? Doesn't look readable. Okay, I will leave Zoom on, but I'm afraid I will need to record a new lecture. Maybe the black marker. This one is bad. This one is also not much better. Let's try to write it big. What?
I could give you my laptop to report.
Ah, yeah, maybe it has better camera. Okay. Then we have a function L, and it takes an observation and action, and it produces a number in 0, 1. Ah, okay, somebody is online. So can you read this? So I'm sorry for, hello, AB. So can you read what is on the board? Hello, I don't hear you. Can you hear me?
Yes, I can hear you.
Still don't hear you. Wait, maybe my sound.
Hello, I can hear you there.
Oh, sorry, it's my sound, I think. Yes, AB, can you say something?
Yes.
Ah, now we hear you. Yeah, sorry, my sound was off. Can you read the board?
Hardly.
Hardly, yeah. Okay, I will try to change the laptop. So there is a nice person. Just a second.